When you think of sustainability, this is a challenge the whole world faces, and companies have put themselves on the forefront of this challenge. 55% of the global 200 companies have already committed to be carbon neutral or to have significant reductions in the future. And about 90% of executives say they're increasing their sustainability investments and that they are committed to making sustainability part of their business transformation. So the challenge is companies are publicly committed around the world. Governments say this is a priority, but how do you actually get this done? And what role does technology play? And what's the range of levers that you can actually pull to have a real impact on sustainability? So I want to talk a little bit about a framework that I think is helpful to think about what to do to have an impact on sustainability and how companies can think about using technology in that. And the framework is a very simple one. And I think everybody needs to think about doing things in both dimensions of this framework. And one is energy conservation. We must think about how we get the same output using less energy for existing assets. We have to reduce demand. So that's one set of activities. And in some ways, that can have the nearest term impact on sustainability is the energy conservation side of the equation. The other thing that needs to be thought about is the energy transition. How do we actually move to cleaner fuels, and how do we actually have a decarbonized fuels that serve all the different segments that exist today? So I want to take you through a little bit of this framework, and what's really exciting about working at Honeywell is we try to address both sides of this equation, both energy conservation and energy transition. So when you think about energy conservation, the most important thing, and this sounds very basic, but it's something that I think companies are really struggling with, is you have to establish your baseline. And today, most companies, when they estimate their emissions, it is done with a lot of assumptions. And there is no real scoreboard that actually is enabling you to say, how am I doing, and how do I manage improvements or things that I'm implementing? So the first step has to be, let's get to an actual baseline. Let's use digital technology, which is very much available today. Let's sensorize our factories and our buildings and actually establish a real-time baseline to monitor our emissions. So this is sort of step number one. And I want to talk about a few different sectors where we think energy conservation is very much possible. First is buildings. Depending on how you look at the denominator, buildings account for somewhere between 25% to 45% of total carbon emissions in the world today. So buildings clearly have to be more efficient, but we also want buildings to be comfortable, and we have to have sort of the same quality inside buildings that we've come to expect. The great thing about reducing energy consumption in buildings is that technology is very much existent today. In most facilities, if you update using the existing building controls but putting smart algorithms on top and some minimum amount of sensors, you can reduce energy consumption in buildings by somewhere between 10 and 25%. Even the most advanced buildings, and I'll give you just one example of in Dubai, the Burj Khalifa, they were able to, most advanced systems, they were still able to recognize a significant reduction when they put smart algorithms on top of their system. So it shows you the power that exists even in very modern buildings. In older buildings, you can have significant reductions in energy consumption by modernizing the controls and putting smart algorithms in that make sure the heating, the cooling, and the lighting work to the optimal level and not to the maximum level that the current controls may indicate that they should. The next area is plants or manufacturing facilities. In manufacturing facilities, if you put in smart algorithms for energy optimization, you probably can't get quite as big of a reduction as you can in buildings because they're already monitored and managed fairly closely. But you can still get high single-digit returns just by adding algorithms to this picture. And this is, again, a very powerful tool that you have within digitalization technology. But the other area that is perhaps incredibly important, that is low-hanging fruit, is reducing gas leakage, and fugitive gases. President Biden at COP27 in November in Sharm el-Sheikh, Egypt, talked about methane. Methane has a huge impact on the environment, and there's very easy opportunities to install equipment to monitor methane leaks, to quantify methane leaks, and then actually go fix them. And these are the type of things that can have a significant near-term impact on emissions. Transportation is another area that is critical to focus on conservation. Here, aircraft routing, there's significant opportunities to be more efficient in that routing. There's significant opportunities in truck routing in other areas. And one of the key technologies that we see as being critical to the future is quantum computing. When you think of quantum computing, what it can take is very large, highly variable data sets and actually come up with ways to optimize that. And when you think of the number of routing and transportation and cargo and others, significant opportunities exist there. Refrigeration is another critical area. We all learned during COVID, and we all see a significant growth in cold storage facilities. And there's very significant opportunities to do new refrigerant gases that can dramatically reduce the energy usage in cold storage facilities as well as all other areas. When we think of perhaps some of the most successful environmental global legislation, the Montreal Protocol and the corresponding Kigali Amendment may be the best example of a global program that had a dramatic impact on improving the environment. And the Kigali Amendment, with bringing the full world into using HFOs and others less globally harming refrigerant gases, is a significant opportunity to have a big impact on conservation. I want to spend a little bit of time now focused on energy transition. An energy transition, similar to conservation, there's no one fuel or one solution that's likely going to solve all of our problems. We need to look at a variety of different solutions. And let me start off with advanced biofuels. There's a lot of transportation assets out there that are going to be around for 10, 20, 30 years that are going to require some sort of fuel. Aircraft and trucks, cargo trucks, are maybe two good examples of this. But what exists today is the opportunity to use advanced biofuels using a variety of different feedstocks, from used cooking oil to agricultural waste to algae to many other things, to actually produce sustainable aviation fuel and green diesel. And this is a significant opportunity for these assets that are going to continue moving for decades in the future to actually have a significant reduction in their carbon impact. One of the areas that I think could be most important for India is ethanol to jet, or ethanol to green diesel. India is a major producer of ethanol today, has significant capacity, but the technology now exists to take that ethanol and produce sustainable aviation fuel or green diesel, and this can make a significant impact on the future of those segments and their sustainability impact. Renewables, another key area. I think we all know battery energy storage is a key thing there. Significant advancements in battery energy technology like flow batteries can have a significant impact on that aspect. And I do want to talk a little bit about the hard-to-abate segments. The hard-to-abate segments, we know, is one of the big challenges. It was mentioned in speeches yesterday and today, things like steel, cement, other segments. But carbon capture technology is improving dramatically. Both pre- and post-combustion, carbon capture technologies can have a significant impact, and as policies are formed around those, that can make some of these hard-to-abate segments really reduce their overall impact. And then on the circular economy, this is another tremendous opportunity that exists in the world today. We know globally, plastics is obviously a key material, and plastics are used everywhere. But current mechanical recycling only enables about 10% of that plastic to be economically viably recycled. The great thing is technology is offering solutions again. Chemical recycling of plastic can mean about 80% of waste plastic can actually be recycled and create recyclable polymer oil that can go into new plastic being created. This is a tremendous opportunity in one of the largest problems that we have in the world. There's also opportunities to use significant amount of waste plastic in road building. And we think of countries like India, but it's true for many countries around the world. The infrastructure investment is significant. If we can also have the circular economy of using waste plastic to build those roads and have those roads be longer lasting, it's really a win-win and a great example of how technology can have an impact on the environment. And then finally, I want to finish with hydrogen. Hydrogen is definitely part of the solution going forward. The key is really to make electrolyzers as efficient as they possibly can. It's a chemical problem, it's a controls and electronic problem, but the good news is there's all of those opportunities to use those technologies to make electrolyzers for both green and blue hydrogen much more efficient. That's why it's very exciting to see the hydrogen policies that India has passed. So to conclude, companies large and small have all made public commitments. The challenge now is how are they going to meet those? And to meet those, there's never going to be just one solution. It has to be a combination of energy conservation and energy transition. Technology, fortunately, as is through the history of the world, offers amazing solutions to tackle both of these problems, both in the near term and in the long term. At Honeywell, we've committed to being carbon neutral by 2035, and we think that's very achievable. It's not going to be achievable with one or two initiatives. It's achievable across numerous initiatives on both conservation and transition. And that's what I encourage all companies and all governments to do, is look at the wide variety of solutions in order for us to have a real impact with our sustainability practices and policies. Thank you very much.